in general form. I won't go through that because you do it exactly the same way as you would do an ellipse. Okay? You put the x's together, and then you put the y's together and do complete the square. Okay? Okay, application problem. Turn to page 629, number 62. So any kind of questions, I'll probably ask you a question very similar to this. Okay, there's one in your homework. Okay, you're going to have 61 for the homework. Okay? But 62, it's a good problem. Okay? It uses hyperbolas. Okay, now I'm going to expect you to draw at least a part of it. Okay? What I'm going to do first is let you read this, okay, and we're going to go to the second part slide, and this is the graph. This is what it's going to look like. So read it first, 62. So let's read it together. Radio towers, A and B, 200 kilometers apart, okay, are situated along the coast with A located due west of B. So what I would suggest here is you would draw it out first. How about a quick draw it? So you understand what's going on. Okay? A is due west of B. So here's B. Due west of B, right? Here's A. Now, they're also 200 kilometers apart. So A and B are going to be on the foci. On the foci. Okay? That is given. You should know that. A and B are going to be on the focus. Okay? And on top of that, they are 200 kilometers apart. So if you split it in half here, cut it down here from 0, 0, I mean A is going to be what? Negative 100, 0. And B is going to be what? Positive 100, 0. Okay? Now, it says simultaneously, radio signals are sent from each tower to a ship, with the signal from B received 500 microseconds before the signal from A. And don't worry about microseconds too much. You're going to see it. It will work out pretty quickly. It will disappear. Those units will disappear. Okay? Alright, so let's go back to the previous slide. So let's look at here. First of all, the foci. 2C is equal to 200. C is 100. Okay? The towers are located at the foci. Okay? Both signals are sent out, but A receives at 500 microseconds sooner. So don't worry about the units too much because the units will disappear. Okay. Now, it says, therefore, we need to get the translational distance. Okay, it's on the x-axis, right? Now, here's a little formula. So this formula you need to know, right? This formula comes from derivation. Okay, if you need this formula, I'll give it to you in the test. But this, you should have this, this is in your book. Okay? That the absolute value of the distance from 2 minus the distance of 1 is 2a. Now, that comes in definition, right? From the foci, right? Remember what the foci mean? The distance from the foci to any point on the curve plus the distance from this foci to that point always remains constant, right? And the distance of this one is just simply 2a. It's nice. The difference of those two. So d2 minus d1 is just 2a. Okay? You need to know that formula. Okay, so using that formula, okay, we can start working some things. Okay, so 300, this is number 8. Assuming that radio signals travel 300 meters per microsecond, so this is your distance, right? 300 meters per microsecond. It's velocity, right? Determine the equation of the hyperbola on which the ship is located. Okay, so we need distance, right? So this is radio waves travel 300 meters per microsecond, and we know that tower A received it 500 microseconds sooner right? So 500 times 300 and over microseconds. The microseconds disappear. So we know now that A is just simply, okay, using this formula, is just simply 150 kilometers. It's really nice. Okay? So kind of nice. So once we know that, that's 2A. So A now is just what? 150 divided by 2, 75, right? Now, we also know C from up here, right? So C squared is equal to A squared plus B squared, and then simply 100 squared, right? Minus 75 squared equal to B squared, just solving B squared, right? Is equal to 4375. I just solved it. So basically my formula is this, right? X squared over 75 squared minus y squared over b squared. That's my formula. Okay? So the only thing that's different here is just use this little formula. Now, let's look at B. B says, if the ship lies due north of Tower B, due north, right? How far out at sea is it? Due north. Go back again. It lies this way up here, right? Yeah. I just want you to realize that this thing is completely skewed off, right? The height here is very small. The height here, the width is very tight. Just, be careful of that. So anyway, the ship is exactly north of Tower B. Why is it a hyperbola? Because of sound, right? Sound travels off like that. It's been scientifically proven. Okay? Okay, so basically you just have to shove in x into 100, right? So x is just 100. Right, it's due north, right? So due north basically says we have to find where y is. If x is 100, go up, you hit the hyperbola, that's where the ship is. Because we assume the ship is on the hyperbola, because the way sound travels. That's why. Okay, so we plug it in, we put in 100 in for x, we solve for y. Y is just simply plus or minus all that stuff. Maybe you have a calculator, okay? And it equals 58.3. So the ship is about 58.3 kilometers from Tower B. Nice. Very interesting. This is how radar works. Simple radar. And basically from that differences in times, you're going to tell exactly where something is. Okay, so if you go into the Army, that's how it works. It shows exactly where the ship must be. Okay. Okay, any questions? No? Okay. Okay, all right. Let me give you the homework. Oh, where's the homework? There it is. Okay, don't worry about 7.3. Just this part, 7.1 and 7.2.